This video is over lesson 82, area of a circle, and it is for my 7th grade math class. We have learned that in order to find an area, a two-dimensional measurement, we need to multiply two lengths that make a right angle with each other. So to find area, you got to look for the right angle. So just a quick review, rectangles, the word rectangle, rect actually means right, so rectangle literally means right angle. Every angle in a rectangle is a right angle. So you just take one of the lengths times one of the widths, and you have your area. Now, parallelograms are kind of like a rectangle that's been pushed over into a slant. However, we have to look for the right angle. So I'm not just going to take this base here and multiply it by the side, because that's not a right angle. So instead, we've got to look for what we call the height. The height, which makes a right angle with both the top base and the bottom base, or the left base and the right base, depending on how your paper's turned. Triangles, in some ways a triangle is half of a parallelogram. If I were to cut this triangle out and trace it on a piece of paper and then flip it around, I could trace another triangle out here and end up with a parallelogram. So every triangle is half of some parallelogram. So if the area of a parallelogram is A equals BH, then a triangle, half of that is A equals 1/2 BH. And then most recently we've learned about trapezoids. And trapezoids are special because they've only got one pair of parallel sides here. And in some ways, with every trapezoid, you could almost imagine extending these non-parallel sides and making a triangle. So kind of like the triangle formula has a 1/2, the trapezoid formula has a 1/2. But whereas a triangle has a single base, a trapezoid has two bases. So when it comes to circles, we still need to look for the right angle in some ways, but it's not as obvious. In circles, it can be easy to miss where the right angle is as we find the area, because most of the time it's not going to be written in. In order to find it, we need to visualize a square surrounding a circle that is then quartered. So quartered, cut into four equal parts. So here I've got my circle. I've got a square surrounding the circle, and it's been cut in half and cut in half, so now it's been quartered. So with our squares here, squares are actually a special type of rectangle, which means just like a rectangle, I have four right angles. So to find the area of any one of these squares, I'm going to take r times r. Well, anytime you multiply something with itself, you can rewrite that with an exponent. So each small square has an area of r, but being multiplied with itself 2 times. So r squared. R here because it's the radius of the circle. So thus the area of the large square has an area of, well, 1, 2, 3, 4 of those r squareds. If we were to spread the circle to fill in the squares, so if I were to shave a little bit off of this and fill in that gap, and then maybe shave a little bit more and fill in this gap, and then shave a little bit more off of that guy and fill in this gap, we would find that it fills a little more than 3 of the squares. In fact, the circle would fill actually pi squares. So that's where that number pi comes in. So you would have approximately 3.14 squares that would be filled in. So you'd have 3 squares completely filled in and about 0.14 of this square filled in. Therefore, the area of a circle, it's not 4r squared, it's pi r squared, which leads to a terrible math joke. What is the area of a circle? Pi r squared. But pi r not square, pi r round. Ha, ha, ha. Go back and replay that if you need to. All right, moving on. So pi r squared. So we don't have 4 squares, 4 full squares, but we have pi full squares, little squares. So there is our formula. And ladies and gentlemen, you do need to memorize that. So we're going to apply this now. We've got a few examples down here. So my first circle here, we need to think this through. So with a length going from here to the center and then across again, this 30 is measuring the diameter. And now this is a very important part, because notice that the formula here says A equals pi r squared. So are we using D in the formula? No, we're not. Which means that anytime you end up with D, you need to think this through and consider what would R be. Well, R, the radius, goes from the center out. The center out. So it's going to be half of the diameter. So half of 30 is 15. So now I'm going to go ahead and fill this in then. So A is the first thing in the formula, then equals. Now we need to remember here that pi is only approximately 3.14. So the moment we replace the pi symbol with 3.14, we have to use the approximately equal to instead of the just normal equal to. So pi is approximately equal to pi 3.14 times the radius squared. So the radius here is just 15. I don't have any units on that. So I could just write this as 15 squared. Now, we're going to follow the order of operations. We always have to follow the order of operations. So think about your PEMDAS. So we don't have any parentheses here. We do have an exponent, so we got to do that exponent first. So A is going to be approximately equal to 3.14 times, and then 15 times 15, or 15 squared, is 225. And then finally, we're going to take our 225, and we're going to multiply it by 3.14. And so our area here is going to be approximately 706.5. Now remember, since no units were given here, we do need to give a placeholder on our answer. And so since we don't know if this is centimeters or inches or miles or light years or what it is, we're going to go ahead and just write units until we find out. However, since it's an area, it's going to be square units. Area will be square units. So 706.5 square units. Now we're going to do it again, but this time we're going to use 22/7 as our approximation for pi. And as we learned with circumference, this is helpful under certain circumstances. It's not always helpful. All right, so here we go. A is approximately equal to, and I'm going to use 22/7 times 15 squared. So A is approximately equal to 22/7 times 225, but I'm going to make this 225 over 1. Since that's a fraction, I'm just going to turn that into a fraction as well. And then for the sake of space, I'm going to give an equal sign here. We can see if we can do any reducing beforehand. Well, I already know that this is just 15 times 15. So does 7 and 15 reduce? No. So since that doesn't reduce, I'll tell you what, 7 and 225 won't reduce. So if you can't reduce the 7 with the radius, you're not going to be able to reduce the 7 with the radius squared either. So hopefully save you a little time there. So 22 times 225. If we plug that in, we get 4,950, and then 7 times 1 is 7. Now remember that fractions mean division. Also remember that you are not allowed to use repeating decimals. So this is not going to come out nicely, I'll tell you right now. So I would say 7 goes into 49 7 times. 7 does not go into, well, evenly, I should say, evenly, so nothing's left over. So you can put a little 0 there. So that's just a 5 then. So 7 does not go into 5, so 0. And then 7 then goes into 50 7 times with 1 left over. So this ends up being 707 and 1/7. And again, since the units weren't given, we have to say square units. So was this a good time for 22/7? No. And why not? Because 7 doesn't go into 15. Because 7 and since 7 is prime, we're looking for it to go into 15, not just reduce with 15. So, but it doesn't, so you end up with a fraction at the end. So it's not the nicest. You can do it, it's not the nicest. Now notice here my two answers are fairly close. So 706 with some extra, 707 with some extra. So considering we're in the 700s, being less than 1 away from each other, these two answers, that's pretty close. That's pretty close. But if you use a different approximation for pi, you can get slightly different answers. Some of them more accurate than others. Which is why sometimes we leave pi as pi, where we will calculate the area, but we'll let somebody else later on decide how they want to approximate pi. So if I do it here, I'm going to get a, and now since I'm leaving pi as pi, I'm also going to leave the equal sign as an equal sign. So a equals pi times r squared. Now we know 15 squared is 225. We've already done that twice before. And then pi technically is a number, but since it's written as a symbol, we're going to treat it just like we would x or y or some other variable. And so I'm going to put my number first, 225, and I'm going to put pi after it. And so now if we were to hand this result off to somebody, if we were working in a company, and that's what we calculated, we hand it off to someone else, now they get to decide how they want to round pi off. Maybe they don't need it to be terribly accurate, and they just round it off to 3, and that's close enough for them. Maybe we hand it off to a different department in our company, and somebody in that department, that next department, is okay with 3.1. Well, then they can round it off to 3.1 and multiply by 225. Maybe we go to a third department and they need it super accurate, and so they round it off not just to 3.14, but to 3.1415926. And they get a much, much more accurate answer. So leaving pi as pi sometimes can allow us to do our algebra more efficiently. Sometimes can leave it then for somebody else to decide how to round it. But if the book asks you to do that, there it is. Last example here. So this time we have to look at our circle and again consider what kind of measurement this is. So it's just going from the center to the circle, which means that this is a radius. So 14 feet is my radius. And remember that the formula is asking for the radius, so this is perfect. This is exactly what we need. So we could easily figure out what the diameter is. We just don't care right now. It's not important. So here we go. We're going to start by using 3.14 like we did last time. So A is approximately equal to 3.14. Now this time, because we have a number and units, all of this is the radius. So if I were to write 14 feet squared like that, exponents in mathematics only happen to whatever they are directly next to. And this is important for communication. This is important for if you're ever doing something on a computer. The computers are going to follow these rules. So this is what is only going to happen to whatever this is directly next to. So just the 14, or just the feet. So since I want to square the entire radius, I need something to group this as one object. Well, that's parentheses. Now understand here that when it comes to the order of operations, we would not consider there actually to be any parentheses, and I know that can be a little confusing. But the reason why we would consider there to be no parentheses in this problem as far as the order of operations is concerned is because look inside the parentheses. Is there anything to do inside of them? Well, no. All the stuff to do is outside of the parentheses. So these parentheses are not here to tell you what to do first. They're just there to tell you, treat this as one object. They're also here, if I don't put a times dot in between these, I have a number right next to parentheses. They can also be here to express multiplication. So parentheses can be a little flexible. Sometimes they actually mean parentheses in the order of operations. Sometimes they mean multiplication. And sometimes they're just there to group things as one object. So as far as the order of operations goes, we have no parentheses because there's nothing to do inside of them. So we move on to the exponent. And so the exponent is happening to both the 14 and the feet. So this is 14 feet times 14 feet. So A is approximately equal to 3.14 times, now 14 times 14 is 196. Feet times feet is square feet. So now again, notice this exponent is only happening to these feet to tell us that this is an area measurement. It's not a linear measurement. You wouldn't measure this with a ruler. This is an area measurement now. Now again, back to the order of operations. Do we have any parentheses here? Again, we would say no, at least as an operation, because there's nothing to do inside. Then we look for exponents. Well, this exponent is just labeling those feet, so no exponents to do. And so finally we look for multiplication. And that's where these parentheses are being used to express the multiplication. So let's go ahead and do that multiplication. So I have 3.14 times 196. And when we type that in, we get 615.44. And then the units that are going to tag along are square feet. 615.44 square feet. All right, next up, we're going to go back to using pi as 22/7. So notice this time, unlike up here, 7 didn't go into our radius. This time, 7 does go into our radius. And so A is approximately equal to 22/7. We almost always use 3.14, which is why that's automatic for me. 22/7, and then times 14 feet squared. We're going to do like we did last time. And I'm going to write this then, I'm going to put a dot there this time, because I'm going to write this as a fraction, 196 square feet, don't forget your units, over 1. And now 7 does go into 196, because 7 goes into 14, it's going to go into 196. So if we reduce this before multiplying, 7 will go into itself once, and then 7 will go into this 28 times. So that's a 28. So now it's really just 22 times 28. So 22 times 28, A is approximately equal to 616 square feet. And see how nicely that answer comes out. So when the radius can be divided by 7, we get a nice, neat answer there. In this case, a whole number answer. So this is a good time because 7 does go into 14. And then finally, we're going to find the exact answer. Well, ladies and gentlemen, the exact answer means that we're still going to use the equal sign. And in order to still use the equal sign, means we're leaving pi as pi. So leave pi as pi and find the exact answer are really just two different ways of saying to do the same thing. So A actually equals pi times 14 feet squared. Now when we write our answer here, there is an order to this. Just like in English class, you've probably learned that there is an actual order to how we put our adjectives. They do go in a certain order, which is just something culturally we've developed and what's natural for us and what's normal. So the order here is going to be number, 196. So number first, then symbol, and last units. So number, symbol, units. So number, symbol, units is the order we write that in. So 196 pi square feet. And again, we can pass that off then and somebody else can decide how far to round that. That, ladies and gentlemen, is our lesson.